So I'm Ray Krug from Netscout, Solution Architect, and I wanted to talk about how we deploy our V-Scout technology, our Netscout technology into an NSX environment. First of all, I'm going to whirlwind through this one because this is about an app, micro-segmented app, and you can see how it's designed. You've got the user, web, application tiers, and database tiers and shared services. So that's how you would micro-segment an application in an NSX environment with different VNIs, and you'd set up firewall policies to actually just control how the applications are actually communicating. So here's an example. It's kind of NSX manager where you see the policies. Any to web, web to web, what ports go where, etc. So that's really tightly securing your application. So that's just NSX stuff. Once you've actually deployed the application, then you want to think about perhaps monitoring it. Or you do it the other way. Think about monitoring and then deploy the application. So what our nGeniusONE platform that you now know about, we register that as a partner console to NSX, which tells NSX and vCenter how to install our agent. Then you press the button to say install on this cluster, and bang, it installs on every ESX host in the cluster the service virtual machine called NSX V-Scout Edition. It does nothing, of course. It just sits there as a virtual machine until you make the VMs that you have in your application. I shouldn't stand in front there. The VMs there, part of the security policy called V-Scout Netscout, which is an inspection traffic policy. As soon as you make those VMs part of that policy, Netscout V-Scout, NSX version of V-Scout gets a copy of those packets. It's really efficient in terms of as one VM talks to another, NSX controls that in memory, of course, sends it off to the other VM, but also sends us a copy. We get the copy of the packets. This is where it gets interesting from my perspective. The Netscout V-Scout NSX edition then does those ASI calculations, the smart data, and just sends that metadata to the nGeniusONE platform where you get all those user interface and workflows. So it's extremely efficient. Processing of that ASI data is done very close to the data, the wire data coming in, and then we're just sending the metadata. We're not doubling up the packets. We're not sending packets across to the nGeniusONE, doubling up the amount of traffic that's going on there. So it's extremely efficient. And I talked about the KPIs, so I don't need to dwell on those again. But of course, you might want to get hold of the packets, as we discussed earlier on, and we can do that. So we can switch on traffic forwarding from a V-Scout and to either the security tool that you want to send it to through a GRE tunnel, or to our consumption device, which is, in this case, virtual InfiniStream, vStream, which can store and process those packets and be used for future data forensics, packet forensics.
How is that non-NSX provision ESXi host able to integrate as well?
Well, you see, this is interesting. So if you think about it, there's two levels. There might be an application layer, like the NSX layer, and there'll be a management layer. So just like when you deploy NSX, you put the NSX servers and vCenter in a management. So we can basically, the V-Scout NSX edition has, if you think about it, two interfaces. One on the NetX side, which is the API that we use to get those packets, and then one on the management side. So that means that we can send that GRE tunnel through the management network, which then can go to a virtual vStream in another network. As you see, that's not part of the NSX environment. Or it could go to a physical one, or it could go somewhere else.
So you can leverage it without even having NSX deployed in this context. That's awesome.
Correct, yeah. So this is summary. I'm hoping I've done this slide, actually, in our discussions and stuff like that, and I think you've appreciated some of the things just by the discussion and stuff like that. So NSX edition of V-Scout is agentless from the perspective of we don't deploy an agent on the VM itself. So that means, of course, we're not taking overhead on those VMs or the application. You don't have to do anything on those VMs themselves, which is kind of important. And the other one was no need to ship packets across the network because we're doing the calculation on the ESX host on which the VMs already exist. So we're doing that very efficiently. And then there's this seamless stuff. So all part of VMware is automation, automation, automation. So we're part of the NSX security policies, so we're controlled, and those can be automated. The install is automated, so you can just get that visibility, and then suddenly Netscout nGeniusONE becomes smarter because it's got that smarter data.
And that does all that through the NSX API, I assume?
The NetX API is what we use to actually receive the packets. I'm going to talk about Netscout in action in NSX environments. So a few screenshots to just show a troubleshooting workflow that I'll cover pretty quickly. I think one of the things that's really exciting is our dashboard. Why is it exciting? Why is it different from other dashboards? Well, because I've been told by people that it's really exciting, because what we're able to do is cut up a complex application. In this case, if you saw the application, it was a multi-tiered application, micro-segmented application. We've been able to cut it up here into the different layers. Web layer, the application layers like stock and offers, which were part of the application, NFS layer, database layer, Active Directory, DNS layers. So we've taken that one application, split it up into its different layers, so we see how those layers are performing by that ASI data, which is telling me the performance and the errors and the latency. So we can change, have a whole load of metrics, but the point is, back to this question, my application is slow. Oh dear, what bit of the application, where does it reside? We can see here, the only thing that's got any latency issues is stock layer here. We're seeing that through that latency, and we're seeing that it's got slow response time. We can see graphs over time to see whether it's just suddenly started to do that or whether it's been doing it for a long time. So that's our dashboard. We're taking this complex application and bringing it down to a single tile. That's the layer that we need to look for.
On the dashboard, you can have, say, synthetic workloads actually listed as a performance characteristic as well.
Yeah. The other one is dependency. We talked a lot about dependency, so now I've blown up the fact that we can use the same technology, ASI technology, to visualize this app. Coincidentally enough, this looks exactly like the architecture diagram I drew, which was the as planned and as designed and as planned, and this is the as is, because this is what is going on in your network now, let's say, the last hour. And we can use this to snapshot it and then compare it. Was there another server there a while back? And the story I always have with this one, and generally, is it's sometimes a surprise. We deploy Netscout onto the infrastructure, discover the network, and there's 2 servers there that they claim that they've decommissioned.
Yep.
So we can click on any of these and see, because we're integrated to vCenter, see which ESXi host it's on. Okay, that's kind of given, but it's still very useful to understand an application. But we can also drill down into that component. So remember, stock was slow. We can actually see what VMs made up. What were the VMs that made up that application, and which one is slow? So we've got a bunch of metrics along there. As I said, application metrics, network metrics, errors and stuff like that. And we can see the performance of each VM and how they're differentiating. So we're now tackled it down, found out that stock 1 is slow. So out of maybe 50 stock servers, 1 of them is slow. And we can also see which ESXi host that's on.
And can you dig into visibility into like a per transaction basis on what's going on?
Absolutely. So remember, we've got access to those packets. If we've got packet forwarding on, we can then do that. And then we can use that to actually drill down into this particular why the latency is. Or in fact, I think I've got a packet analysis one here. But let's just go quickly through here. What errors are going on there? So you'll see there's 501 errors. So we're showing you latency and errors and how they're changing over time. And then this is where we start to forward packets. So we have a consumption engine for forwarding packets, of course. So I'll just quickly go through this. We can actually filter and show what's going on there, which is pretty cool. And then here, this is where we can actually do that forensics. So we can actually drill down and get hold of that. This is a simple 501. It's a REST API. We're seeing what's going on, but we can do this for any protocol that we're analyzing.
So the screenshot you showed of the application dependency mapping, does that scale? Like, I have a customer with 600 racks up here in the data center. How is that going to look in a huge enterprise?
Well, see, that's a very good point, because of course it scales, but it becomes very fine-grained and stuff like that, so that you can actually switch and filter out things that you don't want to see on that dependency map. So yeah, there's various ways of doing it. Don't show discovered servers, show discovered servers, and that sort of thing. Just show certain application components on that as well. So yeah, you can trim it down. Thanks. For that exact reason. We've already talked about this, But how do we do it? You all know the answer to that. We use V-Scout in the hybrid cloud. Because think about the hybrid cloud. I talked about NSX, it's virtualization. We've got that bolt-in into NSX. Hybrid cloud, we can't get access to those packets. We already had that discussion. So what we can do is implement V-Scout as an agent on the VMs, whatever the cloud, whatever the technology here. We talked about Docker, Kubernetes. We talked about Amazon, Azure, Google, bare metal. We can use that agent. And guess what it does? Exactly the same thing. It does that ASI metadata. It translates that and sends it off to the nGeniusONE platform. And of course, we could do that traffic forwarding as well. So from an agent in Azure, I can forward the packets to a vStream in Azure, and then we've got those forensics and deep packet inspection that I just discussed.
And this has no dependency upon NSX.
This has no dependency on NSX, but we can actually create a service, as I showed there, where we've got NSX stuff with the same metrics as bare metal, as Google, not in this case, but in Amazon and in Azure.
And we can ingest it all into the same dashboard effect.
That is the same dashboard, absolutely right, yes. So really, kind of a bit summarizing, you can migrate to the cloud with confidence. This is kind of obvious. Now you know what we do. It's this kind of, you can instrument before your migration with vScout, wherever it is. Then you can migrate it. Well, you can then understand the dependencies and see what you need to migrate. Again, if you inherit an application that you didn't know about, because it wasn't documented correctly, you can discover what it was so you know what to migrate.
That's every application.
It's every
Thank you. I was, yeah. And then, of course, you can migrate it and continue to instrument it with vScout, whether it's NSX or whether it's hybrid cloud. Check the performance, quickly resolve issues before the users start to complain, and then, of course, continue monitor because things don't stop. We talked about dependency mapping and how that might change over future, but performance and changes as well. So here's my summary, basically. Visibility in the hybrid cloud with Netscout, we've talked about that. Migrate to a secure NSX environment with confidence, which is kind of the whole premises of our presentation. And this is what we're doing, and these are some key areas. ASI for application assurance, those key performance metrics for application latency, network latency, errors, message types, the service dependency, the packet analysis, and the packet forwarding.